Ani Bojo, Anangkwendishnakas, Okakaning Donchapa, Michikan and Dodam. Hello and welcome. My name is Kathleen Ryan. I'm the acting manager and the energy manager at the Saugeen Ojibwe Nation Environment Office. Welcome to a new webinar series that we're starting that will focus on environment and our work with Bruce Power and our consultation and engagement with Bruce Power. So this first episode is focused on an environmental engagement overview and a focus on coastal waters monitoring program and how that's connected with our work with Bruce Power. And joining me today for this session is Sherry Leifeich and Emily Johnson from Bruce Power. Sherry Lee and Emily, myself, make up the Environmental and Regulatory Subcommittee, which I'll talk about a little bit later. But we meet regularly to discuss issues of environmental interest and concern related to Bruce Power's ongoing operations, as well as any regulatory items that might come up. And we sort of discuss how to work through these items collaboratively and come up with a mutual solution if there's any issues. So Sherry Lee is the Environmental Regulatory and Research Manager at Bruce Power. Her background is in aquatic ecology, same as mine. She focuses on sort of aquatic ecology in the Great Lakes and has been doing that work since around 2008. And Emily Johnson, who will probably come in closer to the end of the session, is a Senior Technical Officer at Bruce Power. And she focuses on Indigenous relations and environmental sustainability. So to start the session today, I'm going to go through a PowerPoint presentation that talks about our engagement with Bruce Power and the Coastal Waters Monitoring Program. And then if there are any questions, we'll have time for questions. And then Sherry Lee will also be doing a presentation. And then of course, any questions we can answer throughout as they come up, or we'll save them to the end depending on what the questions are. And this video is recorded, so please feel free to share with anyone you think might be interested. So with that, I'm going to attempt technology and hopefully share my presentation screen. Okay, so I'm just going to go through this presentation, and I can't see the chat or the Q&A, so maybe April or someone else could let me know if any questions do come up while I'm talking. Otherwise, I'm not ignoring them. I'm just saving them to the end. Okay, so like I said, this is a presentation that will focus on our engagement with Bruce Power on environmental matters, and then I'll talk about Coastal Waters Monitoring Program and how that connects with that work. So I'm going to start with this, and this just is an overview for some of you who may be unfamiliar with sort of Saugeen Ojibwe Nation and how we work with proponents. So many of you will know, of course, Saugeen Ojibwe Nation is comprised of Chippewas of Nawash and Ceded First Nation and the Chippewas of Saugeen First Nation. And the governing body for Saugeen Ojibwe Nation is called the Saugeen Ojibwe Nation Joint Council. And this council is made up of each of the band councils from each First Nation. And this council is tasked with making decisions regarding projects and processes within the San territory. So the Joint Council doesn't deal with any issues within the communities. They deal with all of the issues across the very large San territory. The Environment Office, where I work, is a technical body that was created by the Joint Council, and our job is to support the Joint Council on key issues related to the duty to consult and ongoing development in the territory. Our larger goal is to protect the rights of the Saugeen Ojibwe Nation membership. And of course, we know that these rights are directly linked with protecting the lands, waters, and non-human beings of the territory. Here just shows a picture of the Saugeen Ojibwe Nation territory. As you can see, the territory is very large. It includes a very large land base and also a very large water base. And you can see that in the darker blue color. As many of you will also know, the fishery in the water is a really, really important part of Saugeen Ojibwe Nation, of who the nation is, their history, and also sort of present day way of life. The San members have a proven and an asserted Aboriginal and treaty right as well as an active land claim, the lakebed claim, and a claim about the validity of the treaties. Connected to this is the court proven right that SON membership has around commercial fishing to the waters of Lake Huron and Georgian Bay. Many of you will have heard of this decision that was made called the Jones-Nadjuan. SON currently operates the largest Indigenous commercial fishery in the Great Lakes, and we know that fishing and the fish themselves are a really integral part of SON way of life, economy, culture, and just overall who the Saugeen Ojibwe Nation people are. And I'm grounding it in that piece because the importance of the water, the fish, and the fishery, and generally the Saugeen Ojibwe Nation rights and environment is really why we focus a lot on working with Bruce Power on environmental and regulatory issues and concerns, because we want to make sure that we're doing the work to ensure that there are no impacts occurring to the fish, the water, and the fishery, and that can be maintained and sustained far into the future. So I'll kind of move sideways a little bit and just talk about the relationship between Saugeen Ojibwe Nation and Bruce Power and how it's evolved over time. So as many of you will know, Bruce Power does not own the Bruce Nuclear Generating Station, but they began leasing the Bruce Nuclear Generating Station from OPG in 2001. And about 10 years later, after they began leasing and operating the plant, SON and Bruce Power entered into a protocol agreement in 2011. And the protocol agreement really sets a framework and consultation protocols for how SON and Bruce Power would engage on Bruce Power's ongoing operations in the territory. And through this protocol agreement, we set up various sort of committees and subcommittees to meet and discuss these important items. So among these committees is Environmental and Regulatory Subcommittee, Training, Employment, Education and Business Opportunities, or TIBO. And there are also other groups that meet to discuss. We meet with CNSC and Bruce Power to discuss safety, operations, and then we also discuss with Bruce Power wealth creation opportunities. Between 2017 and 18, we really started to solidify some of these structures and begin having more enhanced participation and oversight regarding environmental items of significance to SON. And we developed and implemented more community engagements and awareness, as well as opportunities and events to learn more about our engagement with Bruce Power and Bruce Power operations and what kind of goes on at that site. In 2019, we launched the Coastal Waters Monitoring Program, which is supported by Bruce Power. We also entered into a medical isotopes partnership with Bruce Power, and we undertook something called the Mitigation Measures Analysis, which I'll touch on shortly. So this is going to talk a little bit about SON's environmental concerns and the lead up to how the Coastal Waters Monitoring Program began. So in 2018, the Canadian Nuclear Safety Commission had a license renewal hearing for Bruce Power. This means that Bruce Power has to submit to the Canadian Nuclear Safety Commission an application to extend its operations, and for CNSC to review environmental safety and operational reports to make sure that Bruce Power is operating in an environmentally safe and in a way that's safe to human health as well. So at the 2018 license renewal hearing for Bruce Power, SON submitted an intervention to that hearing, and we raised major concerns about environmental impacts, gaps, and uncertainties in knowledge regarding environmental impacts, specifically stating that we thought there was uncertainty about the impacts caused by impingement and entrainment. And for those that don't know, impingement talks about when Bruce Power intakes water from the lake to cool the reactors down, fish will get sucked in to the plant and stuck on the screens inside the plant. So that's impingement of fish. And entrainment of fish means small fish get sucked in again with that water, But instead of getting stuck on these screens inside the plant, they basically get cycled through the plant with the water. So they're entrained into the plant, and then they get pumped out with the water. So Bruce Power does intake water to cool the reactor, and then 99% of that water is returned to the lake. But the water that's returned to the lake is elevated in temperature. The temperature is higher than the lake temperature, higher than the temperature it was when it came into the plant. And we talk about this and we call it thermal effluent. So this means basically heated water. So we had concerns about the environmental impacts of both of these things. We didn't feel like there was enough information to understand current impacts or enough information to understand what these impacts meant in terms of potential climate change impacts in the future. We also thought that Bruce Power needed to complete a detailed mitigation measures assessment, which meant we wanted them to look at all of the available ways that could be implemented at Bruce Power to reduce the impacts of impingement and entrainment and thermal effluent on fish. And we also noted that SON must be part of ongoing monitoring regarding the interactions between Bruce Power's operations and the environment of the territory. As a result of this intervention, the Canadian Nuclear Safety Commission did put a condition in Bruce Power's license handbook, which means they are obligated to complete this requirement to maintain their license, that they had to complete a mitigation measures analysis in cooperation with SON. We're not going to talk about that in detail today, but some of you may have participated in the community sessions that we had about mitigation measures and provided input into that process. So we're going to have another session just to talk about mitigation measures themselves later on in this series. But just to park that was a really important decision that came out of the hearing, and we have worked through that process with Bruce Power. They've completed a mitigation measures assessment and come up with a few mitigation measures that are feasible and may be and will be explored more in terms of how they can be applied at the Bruce Power site. So next came the question about how to address SON's environmental concerns, where our perspective and our position was so different. And what I mean by this is Bruce Power had the position that their operations were not causing unreasonable risk to the environment. The Canadian Nuclear Safety Commission, who is the oversight, the regulator of Bruce Power, they also said that from their perspective, Bruce Power's operations did not pose any unreasonable risks to the environment or human health. And SON disagreed with that. So how do we address that concern where we have different perspectives? And what we appreciated about our approach is we said, we're going to continue to engage on this and figure out ways that we can move forward in discussing these issues and maybe actually gain more knowledge and information. And the way that we worked together on that was actually towards developing the Coastal Waters Monitoring Program. So we worked with Bruce Power jointly to develop this program. And we have some focus areas around Bruce Power, which I'll talk about later as well. We decided the Coastal Waters Monitoring Program would give us an opportunity to collect our own independent data, to employ our own members, and to learn more about what was going on from our own sort of perspective. We also knew that we would be collecting a whole bunch of more data that would be useful to Bruce Power and the Canadian Nuclear Safety Commission in understanding more about the way that Bruce Power interacts with the environment. So we knew that the inclusion of data that we collected through the program would enhance Bruce Power's environmental assessment and annual environmental reporting, and would actually give them more information to provide more analysis kind of on what's going on. It also, the Coastal Waters Monitoring Program has a much broader spatial scale, meaning it covers a lot more area than the area covered by Bruce Power during its sort of regular monitoring of the plant. So our monitoring program covers the entire Saugeen Ojibway Nation territory waters, basically. And this would enhance our broader understanding of the aquatic environmental conditions in Lake Huron relative to the localized conditions at Bruce Power. Because we can't really understand what's going on at Bruce Power if we don't understand what's going on in the rest of the lake. So the Coastal Waters Monitoring Program, like I said, we launched this with the support of Bruce Power in 2019. And not only is it a tool for ongoing engagement with Bruce Power and understanding the environmental interactions between Bruce Power's operations and the lake, but part of Coastal Waters is also an exercise of asserting SON's jurisdiction across the territory and physically being on the lands and waters. It's also part of involving SON community members in on-the-ground work and providing those employment opportunities and training opportunities for people to get more connected with the territory and to see and learn what's going on. We also knew that we wanted to build a really comprehensive inventory of data and knowledge for use in our own ongoing consultation and decision-making processes. If we know more about what's going on in the territory, what the health and conditions are on the shorelines, in the water, it can help the leadership, the SON Joint Council, and the Environment Office make better, more informed decisions about projects that are going on in the territory. It also ensures we can protect our non-human relatives and their habitats by understanding more about where wildlife is, how many there are, and what their health is relative to their environment. We also want to focus on areas that matter to community, providing information back to community members and that opportunity to share ideas and information. Our next focus will be thinking about climate change. How do we use coastal waters monitoring to protect, plan, and adapt for the future? And that also connects with Bruce Power's operations, so in climate change. Here's just a couple of pictures from the Coastal Waters Monitoring Program crew. There's a painted turtle, which are commonly collected in our live nets, and there's a golden shiner, it's also a common species collected. So why would we focus on coastal waters? There's lots of other water, there's lots of other things to focus on, but coastal waters are really important because those nearshore areas of the lake are immensely important for sustaining life for both humans and non-human beings. Almost every single fish species in the lake, and there's a lot, use the nearshore areas for at least one part of their life history. And I always use lake whitefish as a really good example. Not only are lake whitefish like a core sort of important fish species for the Saugeen Ojibwe Nation communities, they utilize so much of the lake, and they're a good species to use on why the health of the ecosystem is so important. So adult lake whitefish live in the deeper, colder parts of the lake. They move around the lake to feed, and during spawning time in the late fall, they start to move up the peninsula into the nearshore areas, into the shoals where they like to spawn, like to lay their eggs. And the shoals, a lot of the shoals are honeycombed. They kind of collect the eggs and incubate them nicely. So these are closer into the near shore. Those eggs then incubate over the winter. And then in the spring, when the temperature is right, the embryos hatch into larval fish. And there, if they're lucky, those larval fish get pushed by the currents right into the embayments all along the peninsula. And that's why places like the fishing islands are so important, because they provide all of this nearshore structure. Larval fish who aren't able to control where they're going, keeps them in those nearshore areas. That's where all the food and the productivity is for these tiny little fish. And that's where they grow. Once they grow during that first year of life, they start to move back out into the deeper, colder water. And that's just one example. But nearshore areas are important for so many species, for feeding during various parts of their life stages, for nursery areas for young, very important for many fish species. The vegetation in wetlands, so the plant structures in wetlands, provide shelter. They provide places to hide from predation for fish. So the nearshore areas with their vegetation, with their structure, serve a really important purpose in the ecosystem. These areas are also really important for water quality. So wetlands actually improve water quality for human beings, and they're really important for human health. They're also habitat for other species other than fish, of course. These nearshore areas are essential for turtles, some snakes, and some secretive migratory and wetland birds. So wetlands provide all sorts of services. That's what they call them, services for human beings. And they're essential to so many fish and animals' survival. And sometimes we forget about the huge diversity of small fishes that live in the lake. We focus on those fish that we see or we eat. So whitefish, lake trout, salmonids, bass. We see those, people fish for them, we eat them. But there's many, many species of small fish and other types of fish that aren't eaten. And they all have a purpose and a place, whether you think about it in terms of in creation or in the ecosystem. These things are vital to the overall health of the lake and those large fish that we like to eat. So it's important to remember them. So through our program, trying to focus on the health of these nearshore areas and all of these smaller and maybe less paid attention to fish. There's also all sorts of other things, not fish, that are also really important in these areas and to overall health of an ecosystem. Phytoplankton, zooplanktons, benthic invertebrates, so tiny little bugs that live in the water and in the sediment. And then all sorts of other fish that you may not even think of. So again, about the program. So we launched the first year of the program in 2019, and we're now in the middle of our third year, and it's very exciting. Once we've gotten through this third year, we feel like we might be able to establish a baseline data set. That means we might be able to understand sort of what the base condition is across these various sites in the territory. Once we begin to be able to understand what that condition is, we want to start looking at 4 sort of key questions. One of them are, what are the current conditions? So what is the current sort of distribution and abundance of fish look like? What does the current health of the ecosystem and these individual sites look like? What are the differences in the conditions between sites? So do we see major differences between the health of sites, say on the Lake Huron side versus the Georgian Bay side? Do we see a major difference between the health of sites in the southern part of Lake Huron versus the northern part? Where do we see differences? And then how do we connect the differences we might see in those sites with stressors in and around the environment? So do we see that there are certain areas that are inundated by shoreline development, cottages, new developments like that? Do we see that their health is decreasing or that there's something different going on there than other places? And when we see these changes occurring, what can we do about it? That's the most important thing. Once we're able to look at this data and say, there's something going on here, we can start to focus on what's going on here and why, and how can we be part of the solution to repair whatever has gone on there. And then sort of at the highest level, it's how do we monitor changes over time? And what changes do we see occurring over time? So that'll be really important as we start turning our minds to climate change and how the water, the fish, and other water beings might start to shift their distribution, where they are and how many there are and how they relate to the environment as the climate, the water they're surrounded in, starts to change. I just want to highlight the amazing field technicians that we have in this program. I'm just proud and astounded by them every day and all the hard work they do. Here you can see a picture taken out front of the Bruce Nuclear Generating Station in 2019. There's Alicia Jones, Michelle Desjardins, and Emily Manser. So they have been working on the program since 2019, and they're continuing to work on the program, and they have worked really hard. And then there's a picture of a blunt-nosed minnow that has all these tubercles on its face, and that's how you can tell this type of minnow is a male and he's spawning in the spring. So overall, the Coastal Waters Monitoring Program, like I said, covers a large area. We monitor nearshore, it's a nearshore focused monitoring program. We focus on fish community. So what is the fish community? And anything incidental we see, meaning we're not targeting turtles, snakes, and birds, but if we see them, we make sure we record what we've seen in that habitat. At all our sites and across the territory, we also monitor temperature, water quality, wetland and aquatic plants, and we also want to integrate SON ecological knowledge into how we understand the information that we're receiving. Here in the pictures, you can see a juvenile long-nosed gar. Some people call these alligator fish. This is a very small stage of this, what gets to be a very large fish. And this is also a juvenile bowfin, who are very, very beautiful fish. They also get very large. They have like a hard plate on their face. They're quite a beautiful and interesting fish. These are two examples of fish that you might never have seen before, but are very common in the nearshore habitats of the territory, and they're quite beautiful and interesting. This is just a picture that shows the overall scope of the monitoring program over the past in 2020, and be very similar in 2021. Here you can see the locations of our fyke netting. So this is where we live trap fish, identify them to see what's in the habitat. We also have temperature loggers. So these are logging the temperature of the water at 3 and 5 meters every 30 seconds. So we're getting a reading of the water temperature every 30 seconds. We then upload that data and we start to look at what the temperature dynamic looks like in each of these sites. So you can see here we've divided the territory into a bunch of different sites. It starts in Kincardine. You see sites at Inverhuron, Bay de Door, Saugeen Shores, all through the fishing islands, Chiefs Point, Stokes Bay, and then on the Georgian Bay side as well. And this goes all the way over to Nottawasaga, the Nottawasaga River on Georgian Bay. Here's just some pictures that show in the top left, this is our fyke net. So this is the main net that we use to collect fish. Like I said, it's a live trapping method. So the fish will swim into this sort of funnel and get trapped in the funnel. And then after 24 hours, they go back, they pull this net out, funnel all the fish to the back and start one by one measuring each one, identifying which species it is, and just checking that it doesn't have any abnormalities, any growths, tumors, anything that looks abnormal. And in these pictures, you can kind of see the variety of habitats across the territory. You have this nice sort of wetland river system here, a wetland here, and then you have something that definitely looks like Georgian Bay. This is just a really short summary of the work that Coastal Waters has done. You can see that even amidst COVID last year, they were able to complete a really impressive amount of work. Sampled a number of regions, upwards of 50 site locations, so 50 individual nets basically set between seining and the live fyke net. In 2020, we had 37 temperature loggers out around the territory. So when I think about Bruce Power, and I'll talk about this next, we have a lot of temperature loggers because we talked about that thermal effluent. So we're interested in understanding more about that temperature interaction. So we have a lot of temperature loggers in the Bruce Power area and then a bunch more all around the territory so that we can compare what we're seeing in those areas. It also shows here the total amount of fish caught, which is actually very impressive. 2019, it was over 75,000, and 2020, it was just over 60,000. And the first year we caught just about 50 species of fish, which is a lot, 44 in 2020. And then you can just see here the difference in the numbers of fish caught in Lake Huron versus Georgian Bay. So you can see in Georgian Bay, there was almost 80% of the total abundance of fish was actually caught in Georgian Bay. And then that almost switched in 2020. So we know things change and the things that we see are going to be different year to year. So we're always gaining more knowledge and understanding. I have a short video to show, and I'm going to show it, I think, after I'm done this next part. So this is going to focus on what we're learning and what we're doing around the Bruce Power site. So as you might have seen on the map, we do have a Bruce Power study area, and when we think about the Bruce Power study area, we've included Inverhuron, which is just south of Bruce Power, all the way up to Chiefs Point. So why did we choose this study area? And then Bay de Door is right in the center. So Bay de Door is central in the study area. It's immediately north of the water discharge channel, so where this thermal effluent or warmed water is coming out, and it is a wetland habitat. It has a wetland habitat characteristics. So we're very interested in understanding what's going on in this habitat, what's happening with fish, water quality, water temperature, vegetation. Inverhuron, which is just south of Bruce Power, is included because it is also in proximity to, there are two water effluent outlets, two water discharges at Bruce Power. So Bay de Door is immediately north of the Bruce A discharge, and then Inverhuron is south of the Bruce B discharge channel. We're also interested in Inverhuron because it is a much different, even though it's very close, it is a much different sort of ecological system than Beta Dor. It doesn't have as much vegetation. The water movement, the water circulation is much different. The temperature characteristics are much different. So we're very interested in, this system. Chiefs Point to the north is also included in the study area because it's relatively close to Bruce Power, but we're interested because of its location relevant to the dominant coastal current. So we know the dominant current, the water current, moves northwards along the peninsula. So it's coming up along the peninsula, Bruce Power, Chiefs Point, all the way up to Tobermory. So we're curious about that because of the water discharge, and maybe looking at how does that current move any of that water north. So we can look at our temperature loggers and begin to understand what the temperature dynamic is in this broader area. And do we see any ways that we might understand more about temperature, fish, and fish habitat by looking at these three areas and how the three of them interact? We also thought Chiefs Point could be used as a good condition reference location because we know it has awesome fish and fish habitat, wetlands, and the data we've collected shows that it has a lot of species diversity for fish and high abundance of fish. We also know this is a very important location to the Saugeen Ojibwe Nation communities. Here you can see sort of a focus zoom on the Bruce Power study area. So here, like I said, you can see Inverhuron, Beta Dor, and Chiefs Point on the left. And there you can see sort of the Lake Huron side and where all the sites are relative to each other. The little dots that are hard to see do show where our temperature loggers are and some of our netting sites are in those areas. So in 2020, we completed fish community habitat, water quality, and detailed water quality sampling across the Bruce Power study area. Detailed water quality sampling and water quality, what the difference is, just to say, is basic water quality we do at every single site when the fish are going to be collected. They measure temperature, pH, dissolved oxygen. Those are the main parameters to make sure to see what's going on in the water. The detailed water sampling is done once a year. We try to do it within 1 day, and it looks at dissolved metals and nutrients, which are how we can kind of tell how things not in the aquatic environment are interacting. So if we see somewhere where there's a lot of phosphorus or nitrogen or things that might be coming from agricultural runoff or metals or contaminants that shouldn't be high in the environment, these are some of the signals we can look at as what's going on in this area. Anyway, at Bruce Power last year, we did 3 fish community habitat assessments, did 2 water quality sites in Beta Dor. We did 6 fish community sites and 2 water sampling sites at Chiefs Point, and 1 community and habitat or fish assessment and 1 water quality sampling at Inverhuron. So we made sure to cover that entire area. At Beta Dor, we caught almost 600 fish of covering 21 species, so good species diversity. And we did something called a WFI, which is a wetland fish index, which basically we've done for the last 2 years. And you use your fish data to determine the relative health of your wetlands. And you can do this at all your sites and basically give them a score and compare their condition. So we're working on making this a more accurate tool for us, but we need more data to do that. Anyway, we use this to look at the health of the system, and we found that between 2019 and 2020, there's no change in the fish community or habitat quality at Beta Dor. So here you can see the wetland fish index for all the sites within the Bruce Power study area. You can see Inverhuron shows up as very degraded, and this is probably because we haven't caught very many fish there, because the habitat is not ideal for high, like I said, there's not really any vegetation structure for fish habitat. So that's probably why it shows up as very degraded. It doesn't have to do with water quality, this one. And then we see that Chiefs Point and Beta Dor are similar in their scores and are ranking as good. And you can see fish species diversity here as well, very high at Chiefs Point, just over 30. Beta Dor, like I said, 21, and then Inverhuron is very low. The last pie chart here just shows all the various species that we caught in Beta Dor and sort of the relative abundance of them. So back to temperature. So temperature monitoring, like I said, occurs on an ongoing basis. We put these temperature loggers on cinder blocks and drop them to the bottom of the lake at various depths. We put our temperature loggers in late last year because of COVID, but we did leave most of them in over the winter. So it began in July last year, and we took data off of our loggers in October. And like I said, they're checking the temperature every 30 minutes. So there's 4 of these sites, temperature sites in Bay d'Or, 3 in Chiefs Point, 2 at Inverhuron. And like I said, we also did water quality at each of these sampling sites. We did find that some of the water quality measurements were elevated for some of the dissolved metals like sodium, barium, calcium, potassium, strontium, and silicon, but they weren't elevated to a level of concern, or we found that they could be explained by local conditions. Some of these things are just explained by regular inputs from sort of human beings living in the world. So we're doing work to really get into what water quality indicators we're looking for and what might signal concern to us. So that's sort of in the works. Here you can see just some of the temperature data that we collected within the Bruce Power study area. So on the left here, you can see the 3 different areas. Bay d'Or, there should be just 3. So Bay d'Or, there's 2 for Chiefs Point and 1 for Inverhuron. So here you can see basically what we would expect is that the Bay d'Or maximum temperatures are elevated above the maximum temperatures at Chiefs Point and Inverhuron, which we would expect to see that. And then we can start to look at what does these temperature differences mean? And does this mean that the water temperature is not elevated at Chiefs Point, meaning that this sort of thermal, this warmed water is not affecting habitat conditions at Chiefs Point and is staying within sort of this Bruce Power area. But this is just a preliminary graph that just helps us get an initial idea of what the temperature dynamic is. You can see at Inverhuron is the most variable, meaning the temperature goes up and down a lot. So we need to look at this too and say, why is this happening? We know that that's a bit of a different system, but it helps us understand the others. And here, this other graph really just takes Bay d'Or out of the graph and shows it on its own. So you can see the temperature movement through the season. Here's some pictures. There's an adult version of the long-nosed gar and the baby version or the juvenile version. And there's a bucket full of various minnows or cyprinids. Sorry, I think I went on a long time. So others who talk about fish know that we can talk about fish for a long time. But Chimigwech, for listening, you can always find lots of information about the Coastal Waters Monitoring Program by going on Facebook, Coastal Waters Monitoring Program, or on our website under fisheries. So anytime you're looking for anything, you can look there. I have a short video to play, but I just want to check with April if there's any questions or anything in the chat that I can't see.
Nope, you're good to go, Kat. There's no questions right now.
So I'm going to try to play the short video, and hopefully it works and technology's on my side. And if not, if it doesn't work, I'll just share the link, and Sherry Lee can then take over. But let me try here.
We as Saugeen Ojibwe Nation members have a deep connection to all of the lands, waters, and non-human beings within our territory. But there is a special connection to the water. We have relied on the water for sustenance and livelihood, while caring for and celebrating it through ceremony and stewardship. This is a sacred relationship, and it's crucial that we uphold our duty to care for and protect our water. The Coastal Waters Monitoring Program launched with the goal of building a baseline inventory of the nearshore habitats and wildlife within our territory. This information will allow us to investigate differences in conditions between sites and potential causes for decreased health. Even in the face of COVID-19, we were able to enhance our temperature and water quality assessment. In 2020, we set 55 nets deployed across 14 different regions within the territory. We caught over 40 different species and sampled more than 62,000 fish. In 2021, we plan to begin our field season in early April with sampling of larval fishes in Lake Huron. Temperature, water, and fish community assessments completed in 2019 and 2020 will be replicated across the territory. Several rivers and creeks will be monitored using electromagnetic backpacks, and an additional region will be sampled. The Coastal Waters Monitoring Program is now one of the largest nearshore sampling programs in the Great Lakes. Many agencies and organizations will look to us for the information collected to enhance our overall understanding of the coastal regions of Lake Huron and Georgian Bay.
There's a nice video that one of our field technicians made last year. But I've taken up all of the time, and I apologize, I didn't realize the time, but I'm gonna pass it over to Sherry Lee, who again is part of the SON Bruce Power Environmental Regulatory Subcommittee, and her and I jam out on our fish nerdiness all the time. So we've been working with Sherry Lee to develop this program and to find ways to integrate sort of our two ways of knowing and understanding into how we do things in the future. So Sherry Lee has a presentation, so I'll put it over to her and she can.
Okay, thanks, Kat. So thanks for having me today. As Kat said, my name is Sherry Lee Feach. I've been working in the Great Lakes for a while. Of course, grew up on the shores, enjoying this every summer, so it's certainly deep in my heart and soul, and protecting these waters is very important, especially to our company, and I'll go through that in a moment. So on this slide, what you're seeing in the background is a picture of the Bruceby station, and I like this picture because you can see here, this is the intake channel that brings the water into the plant, and then this is the discharge channel. And at Bruceby, the discharge has this rock groin, and that's to help move the discharge out into a jet so that there is sort of a smaller thermal footprint of the Bruceby discharge. So, as I was saying, environmental protection is very important to Bruce Power. It's part of our core values, and we have a multi-layered approach to environmental protection on site. It's, of course, as you're aware, the nuclear industry is very highly regulated. We take measures with all of our activities every single day to minimize releases to air, water, and land. And as I was saying, it's regulated by provincial permits, such as our environmental compliance approvals. And we'll be talking to you in a future video a little bit about some of those limits and what that means, and also how we engage with our Environment Regulatory Subcommittee on those approvals and renewals. And from a radiological side, we have action levels and release limits. So that's again to make sure that the radiological effluents and emissions remain below levels, and we strive to always keep those as low as reasonably achievable, our ALERA principle. And then in addition, we have spill response and reporting, and those are just, of course, due to unforeseen events. And there's a system also set up to make sure that those are mitigated and stopped and reported as needed. And the great news with all of this is we talk about these things in our routine meetings. We also share quarterly reports with the Saugeen Environment Office that also goes into that detail. So all of our work is shown in our annual environmental protection report. This report's posted publicly on the external website every year on May the 1st. And you can see a picture here. This is our 2020 report that just came out. And we're very proud of always putting this work together, and it really goes through all of the detail of our environmental program, both the station side as well as the side that we're more involved in on the environmental monitoring side. And it showcases all of the great work. So I'm going to go through it really briefly here, but to really learn more about it, you can certainly look at that report on our website. There is a link. I'll have to make that link available. Maybe in the chat we could put that, just so that you could find these reports. So this is our annual report, and then a couple of years ago, we put together this nice report with our communications team that just gives an overview of the environmental protection program, more as a high-level summary and an overview, and it really goes through that and gives a good idea of that framework. So in addition to all of these annual reportings, we also have our 5-year environmental risk assessment, which is also posted publicly. And this is something, again, we've talked through about in detail. And what that does is take all of our annual data and kind of look at it over the last 5 years and in the past, as well as look at what future operations may be and what some of those predicted things would look like for environmental emissions and the steps we've taken to, again, minimize those. So it's a forward and backward looking tool that then looks at our annual monitoring in the sense of understanding what that means for both human and the non-human biota. So that's an exercise that's ongoing and that's live now, which is really great. And as I said, all of these things are highly regulated. So we have the Canadian Nuclear Safety Commission, which you may be familiar with, is our, of course, main regulator that's looking at, focused on all the Bruce Power operations, traditionally on the radiological side, but now on both the radiological and non-radiological or conventional side. And then they work with the other federal bodies such as Environment and Climate Change Canada and the Department of Fisheries and Oceans. So for my team, we work with Environment and Climate Change a lot on the thermal effluent, of course, as well as with Fisheries and Oceans on our fisheries impingement and entrainment, like Kat explained earlier in the presentation. And then in addition, provincially, we work with the Ministry of Environment, Conservation and Parks, the MACP, and they regulate, of course, all of our environmental compliance permits. So throughout all of this work, as Kat's explained really well, we engage and collaborate with, of course, our Indigenous nations, but also with other stakeholders, other industries, and research organizations. And that's something that I'm really grateful to be part of, a lot of this innovation and research where we're able to do further work on some of these avenues. So for example, right now we're working on an environmental DNA project with students at the University of Toronto to kind of get a better sense of using that tool as a better way to understand changes in the fish community in the lake, for example. So that's just one example of an ongoing project, and one way that we're driving for innovation and using that to increase our decision making when it comes to understanding risk, but also understanding longer term trends, like Kat's also explained in her presentation. So for the environmental monitoring portion, as I said, we take all measures we can to minimize, mitigate, keep our emissions and effluent as low as it can be from operations. And our environmental monitoring program is there to verify in the natural environment by taking samples in the natural environment. And we outline a lot of the maps. I'll show you some here, but again, the details in our annual environmental protection report, or EPR. And as an example, a lot of the things we would look at in the natural environment include water. So that's lake water, it's surface water on site, like we have a stream on site, we have a few ponds on site. And also then partnering with other organizations to understand what those things look like the Saugeen Valley Conservation Authority, to have a look at water quality, for example. We also, of course, monitor groundwater, soil, sediment, vegetation, fish, other meats, and precipitation. And with all of this work, when we first gather the information, we screen it. And so what that means is we look at, for example, provincial water quality objectives and look at our data in relation to what those objectives are to see if anything is screening above those objectives. And there are several different types of screening, and typically we'll use the most stringent as the starting point to understand, to see if anything's screened above. And that's something we've also been supportive with the water quality work that's come out of the Coastal Water Monitoring Program to also show a way of looking at that information to see if anything is screening above. And all of this we do continually. We have annual routines as well as longer term routines for these parameters. And this allows us to assess. And as we understand what may be happening, we can continually improve, meaning we could add samples, we could change our sampling regime, we can look at different frequencies, ways to adapt to make sure that we are verifying the natural environment levels of potential contaminants there. And like Kat was explaining, we do work with partners, and a good example is the Coastal Water Monitoring Program, where we are able to have that data over the larger spatial area, which is amazing, to be able to understand over a bigger time and space scale what that output might look like. So for groundwater and protection, so I'm just going to go through our programs. So the first one is groundwater protection and groundwater monitoring. So this is a picture here of our Bruce B site again. And you can see there's orange dots on this again. These pictures are in our EPR of where we have groundwater wells. And we have these wells in places where we may have large fuel tanks or things that could potentially pose a risk to groundwater if they were leaking. So there is surveillance monitoring at all of these locations. We understand the flow. When we built the station, we made sure it was built with engineered barriers in place so that all water flow from the station is moving back towards the station, not towards the lake. And we look at those, of course, annually and analyze for both our radiological and non-radiological or conventional parameters. And there's a huge program developed around this that follows the Canadian Standard Association N288.7 documentation. So for radiological environmental monitoring, this program has been in place the longest. It's, of course, been around since the plants have been in operation. All the programs have, but this was a big focus way back when, of course, really understanding what the impact of radiological emissions and effluents are on the natural environment. And there's some maps here, again, more maps in the EPR, just showing locations here where we sample in both water and air, for example. So we sample both on site, near site, and then in the local vicinity of the site to understand what the concentrations look like. We look at both drinking water, surface water, and then we also look at a variety of foodstuffs. And we use this for our dose to public calculation, which is also an EPR, and it's been de minimis for many years now. So all of this work is to show that the radiological effluent emissions are well controlled and well below any risk for human health. So we look at this near and far. We also look at it by wind sector to get a sense if we look at predominant air current patterns in this case, where that could be carrying that radiological effluent, where it may be precipitating. And again, we're not, again, it's de minimis. And we compare this then to the provincial background program. So in this top picture here is the provincial background locations. And so they're monitored throughout the province. So we get a sense of what our values look like versus the background. And they're very comparable and quite small as well, both near the site as well as in the provincial background. And like I said, we use that for dose to public. Oh, sorry. So for our non-radiological monitoring program, this is us doing some phyc netting there in Beta Door with the Invasive Phragmites Control Center. This is Janice here who runs that. And we're able to get out and monitor fish. And so for this program, again, we do annual collection and analysis. We look at all the media, like I explained a bit earlier, such as the Lake Huron waters, as well as soil and sediment and surface water. We also have this really great large biological monitoring program that our technician runs for us from site. We do the marsh monitoring program for frog calls, as well as look for reptiles in the bay, as well as on site, understand some of where they're maybe nesting, for example. It's a huge program for monitoring birds. We look at both shorebirds, breeding birds. We do a great survey of bald eagles in Bay d'Or throughout the winter months, and that population looks like it's been doing really well. It's a lot of juveniles a few years back. And of course for fish. So we do the fish work in Bay d'Or as well as in Stream C, and we also do a lot more fish work further off site, which I'll talk about in the next slide. So the monitoring, of course, includes the fish impingement and entrainment in the pump houses that Kat talked about a little bit earlier, and as well as the thermal effluent program, and I have a bit more detail on those. So let's start with the fish impingement and entrainment. So we monitor fish impingement in every unit every single day. So at Bruce Power, there's 8 units, and each of these units has a pump house, and in each pump house there is a fish basket, such as this one. This is an updated design, and it's from this basket that the operators then look and record all the fish here and get estimates of their size distribution. So typically we see a lot of around goby, of course, as well as shad and suckers are the main species that we see. And again, we share this with the SON Environment Office in our quarterly and annual reports. And now in addition, with our Fisheries Act authorization being issued, we have annual reporting as well to Fisheries and Oceans Canada, and also share that, of course, and really have strong oversight of this program. So operators review this every single day. We enter all that information, understand it, look at it for quality in terms of looking at the species composition, their size distribution, making sure all the forms are completed. That's something we monitor daily on site. And then continued oversight of that, we have the Canadian Nuclear Safety Commission, which does inspections, and we've had the SON Environment Office, Kat and some of the coastal water crew come through with the CNSC to oversee this. And one of the good things that's come from that is we've modified the baskets here at Bruce A. I'm saying it's an updated design because we've added some protection here for overflow to better capture all of the material that comes into the basket. So that's been a really great improvement. And this graph here is just showing you some of our impingement and entrainment numbers over time. You can see the trend here year by year. What you'll see in a video that we have, it's about 2,000 kilograms per year using our HPI metric. And again, you can see more detail on that from either these reports or from the EPR. So one of the bigger fish projects we're doing off-site was the Truax Dam removal in Walkerton. This was removed in 2019. And we were able to monitor locations both before and after the removal now. So we're in the after removal phase, just starting through that. So we have 22 locations. You can see the extent here in the map, so on the Saugeen River. And this project was really to help improve fish passage upstream of the Truax Dam to the main, in both the main stem and all of the associated tribs up to where there is other endpoints, such as other dams that are present. So in addition to monitoring the fish in those streams, we do that by electrofishing. We also tagged 250 rainbows to date and trying to understand where they move spring and fall. So we take them at Denny's Dam and follow them with that tracking, both on foot, by car, and with a small plane. So we're able to pick up the individual signals from those individual fish. And this is an example here of an individual fish that you can see moved up, and before the dam was removed, it's not able to get past the barrier. There were times, depending on flow, and there was a small fishway there that allowed some of the fish to move back and go back out. So you can just see these tracks for the different fish. And the company we work with, Biotactic, has great information on that project in more detail on their website. And of course, another great thing that came from these fisheries offices projects, as Kat explained, was the Coastal Waters Monitoring Program. So we're really excited, of course, about that as well. So when we look in more detail about where we've done fish monitoring assessment, we've done that, of course, in Bay d'Or, as well as up by Oliphant with Janice at the IPCC. So we have further locations, as well as one that she monitors down by Kettle Point. We've continued to do our bass nesting surveys. So this is something we've been doing every spring since 2009. It's a very detailed survey that monitors the bass right from when they start to pair up right through to hatching. So it starts in April-May timeframe and moves right through to July. So it's a great way of getting out and understanding, looking in more detail on both Bay d'Or and our discharge channels to see that evolution over time. We are also able to do the creel angler surveys from 2009 to 2017, and Mike Shigana, who you guys know, was a great, did that work for several years for us later in the program, and that just allowed us to monitor boats coming in at both Bay d'Or and Amber Huron to understand their catches and which fish species were being caught locally, and to be able to measure those and send scale samples in for aging. We've also worked in the past on the Whitefish Mark Recapture Program, which is with CORA, with Chippewa Ottawa Resource Authority at the time. So we worked for several years to mark whitefish and then recapture them. This was part of a larger program in Lake Huron, and our focus was on the, of course, the vicinity of Bruce Power. And that work is well completed now. We've also looked for deepwater sculpin with the USGS, and so that's again a fish species that traditionally lives in the deep area as adults, or that does live in the deep area as adults, and then comes into the near shore as larvae, and they are listed as special concern currently in Lake Huron. And this is the project I just talked about with the DNA and the University of Toronto postdocs. So just to say that we've been monitoring pre and post in Lake Huron since the 1970s, so since pre-building any of the locations, and then doing post monitoring after Bruce A and Bruce B were built, and continuing that through the 1990s. And a great thing was there was a research station at Bay d'Or, run by the University of Toronto back in while this work was going on. So a lot of work that's been done to understand over time what's happening in the vicinity. So for our thermal program, I've given a map here of our locations. You can see the locations that we've monitored. These have varied a little bit over time, but these are the locations that have been consistent for about the last 10 plus years now. And then recently we've added some more sites further out. So up here past the Saugeen River. So not as far as Chiefs Point, but the purpose of us monitoring these locations is to understand the extent of the plume. And so these both go from surface to bottom in the summer months, and then just on bottom in the winter months, because they can't stay to surface with the ice and winter conditions. But these have been continually in place, and so it's great that the Coastal Water Program is enhancing these locations by adding more locations, and we'll be using those all together now in our thermal risk assessment and our upcoming environmental risk assessment. So this is again showing continual improvement. We keep adding, we've added locations further afield for better understanding. We've continued to improve the field setup to be able to retrieve these after the winter. And we've done a ton of work on the model, which models the plume. It's a state-of-the-art Mike 3 model that's really been able to provide a lot of insight on those thermal discharges and what they look like year-round. And then I just have some pictures here of on the boat. You can see some of the anchors that we use for the program and the markers. So again, we put in these markers to the Coast Guard so everyone's aware what they are, but if there are fishing, if you are boating in the area, you'll see them in the summer months. So just letting you know that they're there. And that work's also been done historically. Again, there was pre and post monitoring done with the stations as well. So all of this is put into our thermal risk assessment. We really are improving our understanding of modeling of the thermal plume, and also have water acoustic Doppler current profile, 2 of those out as well. Well, right now there's only one, but it's looking at the current speed and direction year round. So all of that is used to better understand the thermal plume movements. We're really working to understand what we're calling our local study areas. So understanding, like I was showing in this picture here, sort of the immediate vicinity of the plant versus the larger lake, like Kat was also talking about, and what that could mean for climate change. And we've done a lot of work specifically on climate change that we may be presenting in a future series of this webinar. And this is very adaptable. It can be updated regularly as required as we learn more. And continue to have more information to put into it. So our analysis goes through several levels. We do a tier 1 and a tier 2 analysis. So tier 1's getting into some detail. We screen our information on the thermal against fish benchmarks. And as tier 2 then gets into more detailed analysis, looking at spatial extent, duration, frequency, and biological and ecological relevance of those temperature differences. And so again, we'll probably talk about mitigation and climate change more, but as Kat already explained, we did a large mitigation review of technologies and did a lot of work together to incorporate not just more of our economic and operational needs into that evaluation, but also better understanding values beyond just the operational ones. As I said, we've looked at climate change and changing weather. There's been prior workshops on this that have had community participation, and we're working further on that right now to better engage and understand how that information will be best communicated for it to be meaningful, and looking at it in a holistic way. That is the end. So I don't know if there are any questions. I'll stop sharing.
The Bruce Power Nuclear Facility is located on the eastern shore of Lake Huron, near Tiverton, Ontario, within the traditional lands and treaty territory of the people of the Saugeen Ojibwe Nation, which is comprised of the Chippewas of Nawash and Chippewas of Saugeen First Nations. Our picturesque site on the Lake Huron shores is a naturally diverse landscape, habitat for wildlife, plants, and fish. Bruce Power commits through our environment and sustainability policy to ensure environmental protection throughout the life cycle of the site and our operations and activities. This includes upholding the trust of the community through open and transparent communication with partners, Indigenous communities, and stakeholders on environmental interests. Bruce Power is dedicated to our role as stewards of our environment. We understand our environmental impact and verify environmental protection through monitoring the environment, collaborating with industry and the community, and driving related strategic research and innovation. A comprehensive and expanded monitoring program is also in place to collect environmental data reported annually to the public and the Canadian Nuclear Safety Commission as part of Bruce Power's environmental management protocols. Our environmental management system provides the tools and programs needed to protect the natural environment, considering the entire ecosystem and supporting habitat. Through annual measurement, sampling, and analysis, we safeguard the health of the environment and the people. Air emissions and water effluent are monitored via controlled pathways. Environmental monitoring and assessment, including fish, air, soil, and water sampling. Wildlife monitoring and thermal emissions to Lake Huron, groundwater protection and monitoring. Environmental risk assessment, incorporating climate change, greenhouse gas emissions, and mitigation. Our monitoring of radiological and non-radiological substances with assessment of the effects on human and non-human biota demonstrates our protection of the environment. Bruce Power is committed to working with Indigenous communities on areas of environmental interest. The interactions between our facility and Lake Huron's water and fish populations are of vital concern to our community. In 2019, Bruce Power and SON implemented a joint coastal waters monitoring program with the goal of building a comprehensive baseline inventory and continued monitoring of nearshore habitats. The program forms a basis of how we understand the current conditions and health of coastal habitats and wildlife, especially fish, allows investigation of differences in conditions between sites over time, and considers the potential influence of climate change. This involves monitoring the nearshore fish community, including larval fish, water temperature and water quality, and aquatic and semi-aquatic vegetation and wetland community. The data will provide a comprehensive ecological baseline of the nearshore region. This information will be collected along with traditional knowledge to incorporate SON values in terms of the fish community, while gaining deeper insight into the aquatic ecology of the coastal waters and wetlands in the territory. Bruce Power honors Indigenous history and culture, moving forward in the spirit of reconciliation and respect with the Saugeen Ojibwe Nation. Together, we share a deep respect of our land, and we will work together to lead by example in the long-term protection of the lake and watershed.
Okay. There's no other question. Oh, you're on mute, Kat. You're still on mute.
Thanks.
Okay.
Well, the good thing is that Kurt can edit out any of those awkward moments from the video, but I think there was no questions during this, but now this video will just get posted. So if anybody has questions at any time, we can answer them directly or answer them during a next video. So like I said earlier, this is the first of many videos on this topic. And I think the next one, and now I don't know, so April, maybe April or Emily could let me know, there'll be another video with Son and Bruce Power talking about sort of environmental matters, I think in a couple of weeks. And we'll be talking about, who knows?
I think it's June 11th. We're going to talk about the Fisheries Act.
Okay, June 11th, we're going to talk about the Fisheries Act authorization. So perfect. So thanks so much, Emily and Sherry Lee and April, for doing the session today. And if questions come up, we'll let you know. And I guess otherwise, we'll see you again and do this again on June 11th.